All right, so I'm just going to talk generally about how you go from what's called rectangular form, your complex number in the form x plus yi, into polar form. So talking about or describing, sorry, the complex number in terms of the modulus and this angle rather than the x coordinate and the y coordinate on the Argand diagram. Okay, so just like in the 3 plus 4i example, you've got a right angle here. So you've got a right angle triangle, mark theta in there. This is my x coordinate, the real part of the complex number. This is my y coordinate, the imaginary part of the complex number. This is my modulus, which I'm just going to call or. That's what's used in your textbook. That's what gets used in complex numbers to describe the modulus when you're going into polar form. Okay, so what I'm trying to do is rewrite x plus yi in terms of or, the modulus, and theta, that angle. So my standard rectangular form is x plus yi. I'm trying to get rid of the x and get rid of the y and replace them with or and theta. So the x is a side in this right angle triangle, and I want to write it in terms of one of the other sides and the angle. So I'm looking for some relationship between the angles and the sides of a right angle triangle. That's what the trig ratios do for us. Okay, sine, cos, and tan. So this is my angle here. So this is adjacent and this is hypotenuse. Which ratio uses adjacent and hypotenuse? It's cos. So the cos of theta is adjacent over hypotenuse is x over or. So if I bring the or over and multiply, or times the cos of theta is equal to x. And now I'll be able to sub that in for x. Do the same thing with the y. So y is opposite theta. So opposite and hypotenuse is sine. So the sine of theta is y over or. Same thing, bring the or over. So or times sine theta is equal to y. And now I can sub back in here. So my z is now, instead of x, or times cos theta, plus instead of y or sine theta times I. This is in polar form. I'm just going to go a couple of steps more. So I've got an or here and an or here. So I'm going to factorize that out. So or times the cos of theta plus, we tend to write the I out in front, I times sine theta. And now, because we'll be writing this quite a lot, or times cos theta plus I sine theta, we tend to shorten it and just take the c from cos, the I, and the s, and we write it as or times cis theta. So whenever you see cis, just don't forget that it just means cos plus I sine. Okay, so cos theta plus I sine theta, but we tend to write it as or times cis theta. Okay, so there is a complex number in polar form. So rectangular form, polar form, we need to be able to go from here to here and from here to here.